Thank you everybody for joining today's IDMP webinar. This session is going to be on Kepware specifically, and then how TDengine connects with Kepware, and then we're going to look into managing real-time boilers with industrial boilers with Kepware. So let's start before anything to kind of look at the agenda. So yeah, that was just the introduction. I'm the solutions architect, obviously. And we're going to look at ingesting data into TDengine, specifically our time series database, and then taking that ingested data and then creating visualizations out of it in IDMP. And then I'm going to give you guys a couple seconds or a couple minutes at the end to ask questions. So please feel free to drop them in the chat as we go along, but I will also be able to answer them at the end. So that'll be nice. Okay, so let's start with kind of the challenge here, or I guess our intro is in industrial environments, boilers, turbines, pumps, they all have their own controllers. They all have different dialects they speak, right? Like Modbus, Siemens, like you name it. The challenge is how exactly do we unify all of these protocols into a singular system and use it in a way that analytics can create intelligent insights for all that need it, right? And the best way to do that is with Kepware. So Kepware, just to give you a background, was designed by PTC, and it's an industrial connectivity platform. Think of it kind of like the middleware that knows all of like the PLC's languages. So when you're looking at sorry, when you're looking at like a Modbus to a boiler controller, or Ethernet compressor to Siemens to an automation line, uh, all of those data need to be exposed to a common interface, and that is OPC UA, or Open Platform. And so in our setup, Kepware is what collects that data, right? And then publishes it to an OPC UA endpoint. And that's how you'll actually be able to see your data at the end. So I'm actually going to show you kind of what the architecture looks like. If you can see my screen here. So this is where Kepware sits. It's collecting all of that data and unifying it. And then OPC UA is being given that data, and then TDengine time series database subscribes to that data, and then IDMP is obviously built upon TSDBs. So you can kind of see like how all of these systems work together. So in our setup today, Kepware is going to collect the live data from the boilers, temperature, pressure, flow rate, and then publish it to an OPC UA server, and you're going to see what that is. But before that, let's just kind of go into a little bit of detail about what exactly OPC UA is. So OPC UA, that stands for Open Platform Communication, and then Unified Architecture. So it's a vendor-neutral strategy that defines how industrial devices are able to connect in a structured way. So it's platform independent, so you could be on Windows, Linux, and like Mac, it doesn't really matter. And then every data point carries context, so it's like a model-based design, right? And it's secure by design because it's built on top of encryption and authentications. So when Kepware is actually publishing the data over to OPC UA, like let's say boiler has a temperature metric, it isn't just a number, it has a metadata type engineering unit, and that structure is what it like kind of makes it perfect to ingest into TDengine, because it carries with it a timestamp, and a data type and an engineering unit, so you'll actually be able to see that. So now let's connect it all together. To start, before we do all of that, actually, there's a few prerequisites. So you need to install Kep Server X on your local machine. Discretion here, it is mainly for Mac, it's mainly for Windows and Linux. Mac doesn't actually support Kepware, so just something to keep in mind when you guys are setting it up. And then there's a data set that you need to download from Kaggle that's going to be be our industrial data. So as you can see, I am doing it on Mac. So we will have a version for Mac that simulates a Kepware server, which you guys can also try out. So if you're on Mac, that version is coming as well. So there's two ways you could do this. I could do this in the TDengine cloud, which is our cloud instance, right? So that's something you guys can sign up for, and you get a very simple free trial, and everything's just ready to go. I'm doing it on the Docker instance. So I'm doing it on the Docker version. So I'm going to actually use this version right here. And I'll link that in the chat if you guys want to take a look. It doesn't really matter what version you use. The demo does say the cloud, but you're free to use Docker or the cloud to do this. Okay. After that, we actually need to create a data source named CSV Boiler. So this is all going to be on the Kepware side of things. So you're going to go into your system and then create a data source named CSV Boiler, and then select a driver, obviously, right? So you want to make a Microsoft text driver, point it to the directory where this data set is. So this Kaggle data set, I'll click on it for you guys to see, so you can see what it looks like. You actually just hit download and download a zip, and wherever this lives, you're going to point it to that. And then after you point it to that, under data source, choose CSV Boiler, and then advanced simulator is another option, and you can pick the advanced simulator driver. And then add the device name under the data set, set the intervals that you want. This is truly up to your preference. And then in Runtime Connect it to Runtime, and then click on Boiler 1 and Boiler 2 devices, and you'll see the data automatically generate. And then once you do that, the key thing that you want to do inside Kepware is actually launch the OPC client. So that verifies whether the data is being correctly simulated and generated. And from that, the Kepware sort of specific configuration is already done. So this is really easy to do. There's not much setup to do here. You just click download on the PTC Kepware website. They'll have a couple options here. Just find the version that works best for you, and then all you need to do is download demo, right? And it should be enough. It'll run for around 2 hours, so you'll have a limited time to play with it. But my simulated version on Mac, that should run forever. So if that's something you're interested in, please let me know, and I will go ahead and send that to you. So after that, you're going to go to your cloud instance of TSDB. So to your discretion advised, this is for the cloud. So if I click this, I can just go to the time series database on cloud, and that's what it looks like. But if you're doing it on Docker, you just go to the localhost connect for 6060, which is what TDengine IDMP or TSDB is on cloud, right? So once you've done that, you're ready to start. So you'll be greeted with a screen like this. You could see your instances, and then you want to go to the portion that says Explorer, right? I've already done it, but you guys just want to go click here, create database. You can call it boiler test, and done, ready to go, right? So this is the database that your OPC UA server is going to point to. So once you've created that and entered your credentials for Kepware, you want to go back and then just click create and then go to the Explorer. So this Explorer, and verify that this is made, right? So you can actually just click view, and as long as you see true here, it should be ready to go. And then once that's done, now the crux of this, or the main problem that we're trying to solve, is ingesting from all these different formats, right? So this portion right here. So to actually get to this connection, you're going to want to use the data in portion. So when you go to data in, you're going to see it right here. And then once that's ready, click add data source. So I'm going to go here, click add data source, right? So once you click add data source, you should see a ton of different options here. What we're actually going to pick is the OPC UA configuration. With the OPC UA configuration, you actually need an agent to help you parse this data. So what we can do is just click create new agent, and then here it kind of gives you the backstory on this. But TALSEX agent is like used in certain scenarios, especially for OPC UA and DA, and it's an agent that can be deployed on the same server as the data source, and it's just going to help you get that data successfully. So you can see in shell how to actually install it, and then you can verify it in terminal with this command. And then afterwards, generate a token. You can enter any name for it. So uh, you just need to follow the steps on the screen to make sure that it's targeting the agent on the same machine that the Kepware server's on. So, and then also once this is done and you've clicked run agent, you need to select your database too, right? So that database that we just made, just click on it over here and configure the connection information as follows. So like, uh, you're going to want to run that command to find your IP address. So that exact same command that you're going to use for the agent also provides you with the IP address of the machine running the agent. So you're going to want to put that same endpoint over here, and then you're going to want to check connection. Obviously, I don't have one right now because I've already done it. But when you actually do check the connection, you're going to see a little green icon here that indicates that connection is done. So that's the best way to see it. And then under the data set, you're going to want to make sure that you set the correct CSV template. So select your file, and at the bottom you should be clicking on the data points, right? So for me, there's a couple different ones that you can actually click on. So right over here, you're gonna have some basic information under data sets, and then you select. So once you select the data points portion of it, just go ahead and fill it out with what's over here. This is already pre-made for you guys, so you could kind of don't have to worry about setting intervals and deciding exactly when to do that. We've already done that for you. So go ahead and just update it with these settings. And then at the bottom of the page, you're good to go. So once you're good to go, you just click add and then go ahead and just click submit. You don't really need to touch anything else. And then once you click submit, your data set will be ready to go, right? You'll be able to pull. We even have a nice description of OPC UA here if you guys want to read more about it, and then what exactly the solution is. And then actually you can go to the site itself and check it out. So that's a cool thing you could do. So I've already done it, but when you do it, you should see it running here. You should see the task and the agent running. And the best way to look at it is actually you could see your metrics populate. So once your metrics do populate, it'll pop up. But that is the TSDB side of things. And the best way to verify this is actually through the Explorer. So I could do it through Terminal if I wanted to. But I think the most useful way for you guys to see if your data is populating is actually going into your database, and then clicking on a boiler and then seeing the data, right? That's probably the best way to validate that it's there. Your data is going to look a little different. Mine is the Mac version, of course, but yeah, just validate that the data is there, and then you should be good to go. So where do you go from here? Well, like I said, we're going to the second part of that connection is now that we've solved the issue of getting our data into TSDB, how do we actually create visualizations out of it, right? So how do we create things that can actually help us in terms of creating like element templates, cataloging this data, and then creating some kind of insights that we can use. So the best way to do that is through IDMP, which we've already built. IDMP is built entirely on top of the TSDB database, and you can actually see the IDMP database right here. So whenever you add something to IDMP, you'll be able to pop through and look at it at this database because IDMP is a consolidated database that's built on top of TDengine time series database. And right now you can see I have that same data in here, and good to go, ready to go. And I'll actually show you guys what that looks like. So this is what IDMP looks like. Right now I have two different elements in the elements tree. But before we even get started, the most requested feature and the feature that people are usually looking forward to for IDMP is actually the you want to see that the AI connection is up and running. So you're going to go to admin console. You're going to go look at your analysis, your connections, and you should see two. You should see one for the AI connection of your choice. So right now I'm using OpenAI, but again, we're model agnostic. So you can go here, click edit, change the model that you would like, change exactly the URL point. So we work off an endpoint system. So as long as you have an endpoint and an API key, and you know what model you want to use, you can go ahead and do it. So I'm going to go hit discard here because my connections are already in use. But once that's done, we want to see kind of the different things in IDMP that you could do. But first, we want to actually go to libraries, and then I want to show you guys a couple interesting things. So one of the most interesting things that you could do is actually make element templates, right? So you can create these templates to give you standardization for different things. So uh, in our situation, we are actually going to define one for air duct system, right? And then you can. I've already done this, but you would just enter air duct system, and I should space that. That doesn't look right. Okay, cool. So yeah, you'd enter air duct system, and then set an element naming pattern, which we've already given to you guys. So you can actually click it like this. So just copy and paste that naming system, and you should be good to go. You could add additional attributes to this. Right now, we don't really care about that, but you're gonna go ahead and click. You're gonna go ahead and click save, and then you should see that air duct system pop up right over here. You could even give it a description if you wanted to. So we allow for entire customization of everything. So you could take that and create that attribute template, and you're actually able to use it in anything. I've already gone ahead and made all of these, but if I wanted to, I could add a new element reference over here, and actually put that right over there, right? So I'm able to see that. Actually, we're gonna also adjust some things in the air duct template. So you can set a default attribute here. You can categorize it. So I could say auto imported. This is an auto imported. So you can make your own categories. You can set a base template if you have one. You can give a description. This is an air duct template. And what we're actually doing is just creating a data reference, right? So once you do that, you want to also notice that. Let me go ahead and save. But this is going to allow you. There's a couple different options you can mess with. I'm going to let you guys look at that on your own time. But you essentially want to point this towards your database that you've made. So when you get the prompted screen, make sure you point it towards this boiler database, which will automatically pop up in IDMP. But before we do that, actually, I just forgot a slight thing that we should do. We actually need to import our data. That's actually the most important part. So you're going to want to go here, click Easy Import, and you'll see that your database is already popped up. So don't really need to touch anything. And what all you need to do is adjust it the way that you want in terms of tags and metrics. I will let you guys do that as you want, but this is how you would adjust it. And then once you click rebuild, you would actually see this data in here. So right here, I have a hierarchy. This is an elements tree, and I can actually see this. So you could see that I have multiple plants. I have multiple areas within those plants, and then I can also use that air duct system right here. So this for this, and then I want to add a new child element and reference template, and then I could click air duct system, and then it would pop up right here. So yeah, you could actually see that air duct template, and uh, even with the attributes, we can adjust those the way we want, right? So UOM class, we can adjust that. So like what kind of number system do we want to use? All of that you can do. So if I wanted to do cubic meter, I could do that too. If I wanted to do area, I could do that too. Anything can be done here. So that's how you would add that reference template. So what can I do with all this data once it's in there, right? So TDengine's key feature is the analysis portion that we can do with AI, obviously. So I'm actually going to go back to show you the panels that I have already pre-generated for us. Let's see. So all you need to do is pick an area, and then let's go to a single element. Let's actually go to boiler number. Let me pick a random boiler. Let's go to boiler number 2. So you'll be greeted with this screen. Usually we'll say AI is generating because it is indeed generating. So let's give it a second. And it's generating the data based on the aggregated context of everything you have. So it should pop up here. I'm not sure why it's taking some time. This is a LLM issue. But here, let me just pick this. Cool. So you're going to get a kind of three different ways to make panels, right? So you can make them through AI suggestions, which you could turn on and off, and then you can like the ones that you want to use, and then you could dislike the ones that you don't want to use. So if I don't want this one, I can, and if I don't want this one, I can too, and I can even add more suggestion. So I like this one, so I'm gonna go ahead and click that. Let's give it a second, but it should just generate the panel for me, right? Um, Generating new panel. Unsure why the LLM is being like this. OpenAI is usually pretty good about their API calls, but it seems like because it's a demo, they're giving me a little issue here. So let's see. But yeah, so you could generate it that way. You could also prompt this exact same thing. So if I just type the flow output for a pressure sensor, or if I typed one of these, I could easily get that up and running. So as you can see, both of these are up. I could just click view. So if I wanted this exact template, I could just type it and then create it. So you could see how someone's not a source expert, they can do that. And then you can also make a panel. So right here we have a ton of metrics. So I'm going to add this metric for the last 12 hours. And I can add multiple of these metrics. And then I can do a multiple lanes feature. I think the last 12 hours is pretty bad because I have too much data. So I'm going to do a last day. Um, and you could kind of see visualizations of that. And then you could turn off multiple lanes if you wanted to. I think this is the same data actually. So I'm going to pull that out. And then, so this is, you could also do it for the child elements of this. So if I wanted to add like air duct system, I could also do that. I'm able to change the kind of chart it is, so I can make it a bar chart. Although bar chart doesn't make sense in this scenario. I think scatter probably works the best for this situation. I can create predictions, right? So I don't have TDGPT installed, but if that's something that you're interested in, you could also make predictions. I could create an axis. I can create limits. I can add a transformation. I can add a legend, create a table of sorts that you could actually check out. I can hide the legend, so if you don't want to see it, you don't have to. The legend values could be the minimum or the maximum, and as you could see, they're popping up here. There's just a ton of data, so it's kind of hard for it to see. I can make the conditions whatever I want just through math. I can label this panel uh, air duct system last day. And I can just go ahead and click save, go back, and that template's already made. So if you wanted to see this data for, I don't know, for the other templates, I could also convert this to a template. So all of the other ones would inherit it. And then what can I do when I actually create this? Well, I can use these visualizations and make a dashboard out of it. So I'm going to show you guys how to do that. So if I go to the dashboards page right over here, click new dashboard, you'll automatically see these. So I can just add these two to the dashboard, and you can see that they're already there populated. And I can just pull both of these, and you can kind of see how you can create these dashboards to showcase this data. And you could just call it demo dashboard. I can add images to this. I can add text. Just a really easy way once you use LLMs to create these insights to actually share them. So I can go ahead and click save, go back, and then this dashboard is ready to present, right? So already ready to go, and then you can go ahead and show this off. So that's one way you can use AI in TDEngine. The other way is for the industrial use case is through analysis. So we're going to let AI generate the analysis here, but analysis is real-time tasks that AI generates for you. For instance, if you want to see how exactly a boiler is behaving, or what AI thinks you should look for, you could create an analysis. And an analysis is going to be generated based on the attributes you have. So you can actually select the attribute that you want to measure and then add it to the analysis. Let's hopefully AI has generated something by now. I think there's just so much data that it's taking some time, but basically you can do the same thing that you could do with the previous instance for panels, where you could prompt that analysis. And as you can see right here, it's just generating questions for you to look at. But again, it's going to give you suggestions. You can like and dislike based on the ones you like, and it'll generate more similar to that. Or you could just prompt it. So uh, once those questions are generated, you'll see it here. You're able to pick whatever trigger type you want. So I could have a data input trigger type, a sliding window trigger type. Let's say um, boiler temp over a certain amount. And then I want it every 5 minutes. I can do a sliding window. And then let's do click an attribute right here. And then you would just create an expression. So, right. So you'd add a mathematical expression that calculated that, and then you'd be good to go, hoping that the AI here is going to generate. There you go. So yeah, this is what you would see. And then you could pick the ones you like and then dislike the ones you don't. So let's see. Minimum. If I don't like one, I could do that. And if I do like one, let's say I want this one. So I want to calculate the sum of the total output of this one. Uh, as you can see, there's a sliding window trigger type every 15 minutes. And then I'm actually going to not enable it upon creation. So it actually generates here. So I can click save. Some name format is wrong. Okay. To get rid of that, to make that right. And then click resume. And just like that, I have real time, and it also tags it as AI generated. And when I click refresh, I can see it running. So once you get these analyses for different metrics, what you could do with them is actually generate events, right? So right here, I'm going to click generate test data event, and then AI event template, and then go for this analysis right here. And then, so sum of the steamer, and then I'm going to hit confirm. And then this event's already up. As you could see the severity level. I can add an annotation. This is a demo event. Click confirm. I can see a notification record. So you can actually acknowledge this, right? So if I click ACK, I can acknowledge it. And you could see a notification record. I could look at trend chart analysis for the data. This is a little too far of this is overarching, so this one doesn't actually have data in it, but you could see a trend chart analysis. You could send an email alert, so I actually get a notification record. So I just sent a email, but that's another thing you could do with it. You can, again, there's a description here, there's a reason. Different people can acknowledge it, and you can actually add different people to this. So if I go to the admin console and I click user management and I go to users, I can add another user, right? So somebody specifically who's able to access certain roles, and then you could see how that'd be helpful for certain elements and certain people that wanted to manage this thing. So we have that inbuilt. So those are some of the ways you can use TDengine to create these intelligent insights for you. In this solution, let's see. Let me go back. So in this solution, we use a combination of TSDB and IDMP, and we did rapid asset modeling, right? So IDMP integrates with TDengine TSDB. As you saw, the database is built on top of it. And then for critical industrial equipment like boilers, you're going to want to actually see this. So because it is in a single column model, you can use it to build asset insights really fast. So the monitor objects are displayed in that tree structure, and it makes equipment access easy at a glance. There's no configuration, no scripts, no queries. All the collected data is recognized immediately by IDMP. So there's no hand holding on your part. And then for the AI part of it, there's no SQL or scripting needed. Simply describe what you want and it creates it for you. That brings the barrier for data analysis down to almost zero because you don't really need a source expert. And then when a new device or piece of equipment is added to the Kep server, there's no setup needed. The equipment will automatically be added. That saves you a ton of manual effort. So in conclusion, we are using these real-time analytics combined with AI to kind of create a faster connection. And this isn't like a static alert system, right? It's an agentic AI assistant that helps you throughout the process. And we even have a chat in there, so you guys can actually prompt our agent to find specific information about different aspects of it. Let me actually show you that really quick before we recap here. But I can actually I can actually prompt our agent to give us specific information. So if I click this, what is the trend of these two pressure valves in a boiler? It's just gonna think for a couple seconds here and then give me information. I only have 2 days worth of data, but that's what it would look like, right? And you could just prompt that. So it removes the need for people to be source experts, pretty much. Also, we provide real-time analytics. So you could also stream this data through TSDB, and that's another documentation that I can point to. But to recap everything we went over today, we let's go to that ending. To recap, we use Kepware to bridge that OT layer, so speaking every PLC's natural language, and then OPC provides the communication layer that we used, and then IDMP ingests the data from TSDB that subscribes to that OPC layer, and then you can use the inbuilt AI tools to create real-time analytics for your industrial data. This architecture brings IT and OT together, so your teams will have easier visibility and then faster sharing and decision making. And I've also left one of our VP's emails too, so you can reach out to him. And this is a QR code that you can reach out. And we also have a Discord server for those who are interested.